So now let's try out some examples involving those inverse trigonometric functions, or integrals that result in inverse trigonometric functions. So in our first example here, we have the definite integral from -1/2 to positive root 2 over 2 of 1 over the square root of 1 minus x squared dx. You'll notice that this integral, or this integrand, is exactly in the form that is tied to the inverse sign, or the arc sign, which means that we can go ahead and evaluate this directly and say that this will be the arc sine of x going from -1/2 to root 2 over 2. So this will give us the arc sine of root 2 over 2 minus the arc sine of -1/2. Now here's where knowledge of the unit circle is going to come in really handy. We're looking for the quadrant 1 angle whose sine is equal to root 2 over 2. That of course would be pi over 4. Then we'd be looking for the quadrant 4 angle whose sine is equal to -1/2 within the appropriate restriction. That would be negative pi over 6. Getting a common denominator for these two, common denominator is going to be 12, minus a negative can change to plus, and we'll have 3 pi over 12 plus 2 pi over, obviously I meant 12 when I wrote 6. So final answer for this one is going to be 5 pi over 12. Hopefully this demonstrates that knowledge of the unit circle is going to be pretty imperative for these problems. Next up, we have the definite integral from 1 to the square root of 3 of 1 over 1 plus t squared dt. Now with this in mind, this is once again in one of our basic forms where we can integrate this directly and come up with the arctangent of t. This will be going from positive 1 to positive square root of 3. So this will be the arctangent of the square root of 3 minus the arctangent of 1. Now, arctangent isn't nearly as easy to figure out as arcsine, so really what we're doing here is we're saying I want this angle minus this angle. In both of these cases, we'd be talking about the tangent that's opposite over adjacent, so root 3 over 1, and for the arctangent of 1, that's 1 over 1. Hopefully you have some right triangle skills underneath your belt and can recognize that the first angle is pi over 3, and that the second angle that we have over here is pi over 4. Once again, if you get a common denominator for these as being 12, that'll be 4 pi over 12 minus 3 pi over 12, for a final answer of pi over 12. And finally, in our third example down here at the bottom of the page, we have the definite integral from 1 to the square root of 2 of 1 over x times the square root of x squared minus 1 dx. Now once again, this is in one of our basic forms, and this integrates very nicely into the arcsecant of x. Arcsecant of x going from 1 to the square root of 2. So this will be the arcsecant of the square root of 2 minus the arcsecant of 1. Now, secant is going to be the hypotenuse over the adjacent. So in terms of right triangle trigonometry, this one is saying with a hypotenuse of the square root of 2 and an adjacent of 1, what is that angle? Whereas this one is saying something a little bit more basic. I guess what we could do with this is just point out that this would be the arc cosine of the reciprocal of this. So the arc cosine of 1. Now with that in mind, these angles, the first one would be pi over 4, no problem there. And the second one would be the angle whose cosine is equal to 1. That, of course, would be 0 radians. So a final answer for this one is going to be simply pi over 4 for a final answer. In the next video, we'll get into some more advanced forms where some substitutions will be necessary.